Hi, and welcome to ArcStar, home of the best quality, most complete, and easiest to use plasma tables. Today, I'm going to talk to you about how to buy a plasma table. To begin with, there's a lot of different manufacturers to choose from, and nearly all of them will tell you two things. First, that they have the best quality table, and second, how easy their software is to use. Now, obviously, that can't be true. Not everyone's table can be the best, and clearly not all the software can be the easiest to use. This video will help you to identify what factors you should look for in a good quality table, and second, what software is truly the easiest to use and why. Alright, so let's get started. To begin with, a plasma table needs to be rigid in order to get the best cut. Now, some manufacturers use bolt-together aluminum frames, but that type of construction simply can't match the rigidity and precision of welded steel. A steel frame isn't going to warp under the high heat of a plasma torch, and it also provides the solid foundation necessary for precise gantry movement. A steel frame won't flex or shake during rapid moves, which is essential to precision cutting. Remember that to make a precise cut, the torch always needs to come back to the exact same spot. A lightweight aluminum frame table can shift during rapid moves, which can cause your material to also shift, causing your cuts to not line up properly. The gantry spans the table and moves front to back, or what's known as the y-axis. In general, the higher the gantry, the better, because it makes it easier to load and unload materials from the table. The gantry also needs to be rigid so as not to flex during rapid movements. Another aspect to check is how the gantry is powered. Some manufacturers only use one motor to drive the gantry. Using a single motor to drive both sides can cause binding, which can cause your part to be skewed or distorted. It also limits the speed and the ability to quickly reverse directions, both of which lowers the quality of your cuts. The best tables will always use two motors, one on each side of the gantry. The carriage moves left to right on top of the gantry in what's known as the x-axis. The best designed tables will use a step-down pulley system in order to provide the most torque. The lifter assembly is mounted to the front of the carriage. The lifter moves the torch up and down and precisely maintains the correct distance between the torch and the material. Maintaining the proper distance is crucial to getting good cuts and also increases the life of your consumables. If you haven't heard the term consumables before, these are the parts that normally wear out when plasma cutting. Bearings refer to how the moving mechanical parts of the table, such as the gantry, the carriage, and the lifter, move in relation to each other. As we would expect, precise movement is essential to obtaining a quality cut. The least desirable choice is to use open bearings, which ride directly against the frame of the table. With this method, there's no way to constrict lateral or vertical movement between the two components. Now, this method is a very popular choice with low-budget tables, as it is very inexpensive for the manufacturer. Round rail is the next best choice. This provides straight linear movement and is a definite improvement over plain bearings, but it still doesn't offer any lateral stability as the components can still rotate around each other. The best solution is to use the linear guide rail. This method precisely guides and controls both lateral and vertical movement. This is because linear guide rail blocks have 4 separate runs of bearings within each bearing block. The combination of 4 precisely guided circuits restricts the motion between the parts. Although linear guide rail costs substantially more, it's the only solution that guarantees precise alignment and repeatability. The drive mechanism describes whatever method is used by the motors to produce table movement. Common drive methods are lead screws, ball screws, belt drive, or rack and pinion. Lead screws suffer from not being fast or precise enough. Ball screws are faster and more accurate than lead screws, but they can whip and resonate as they increase in length. Belt drive systems suffer from not having good repeatable positional accuracy. The best tables all will use rack and pinion drive. This method has the speed, the strength, and the repeatability necessary for precision cuts, and accordingly is the best choice for professional tables. Slats support the material as it lays on top of the plasma table. The slat support system needs to be rigid in order to hold the material in place while it's cut. Further, the slats should be closely spaced together so as to hold or bridge smaller pieces. Additionally, the best slats are pointed or have what's called a shark tooth style look to them. The shape serves to minimize the impact on torch height control, which can mistakenly think your material is thicker if the slats are straight and happen to line up with the cut. Still, cheaper tables continue to use straight-sided slats because they're less expensive to manufacture. Believe it or not, some tables don't even include slats. The best solution is to use heavy gauge steel shark tooth style pointed slats, which provides a maximum support and minimal impact on torch height control. The fact is, if not dealt with properly, plasma cutting can leave a gritty, smoky mess. Now, most plasma table photos on the internet, including ours, only show you pictures of factory fresh, newly painted tables. However, buying a table without considering how to properly eliminate the smoke and dust can be a costly mistake. Today, there are roughly 3 different methods on how to deal with the smoke and fumes created during the plasma cutting process. The least expensive and worst method is to try and ignore the matter entirely. This is obviously not recommended, as plasma dust will soon cover everything in your shop. Unfortunately, it's not uncommon to see videos advertising plasma tables with absolutely no smoke elimination system in place, cutting parts in perfectly clean shops. Rest assured, videos like these are not realistic. Using water to capture the smoke is inexpensive, but also has some serious drawbacks. This method uses a tray of water that's built underneath the slats of the table. The idea is to catch the excess smoke and particles as the plasma arc cuts the material. The first problem is that the metal particles created during the cutting process can cause the water to become conductive. This in turn can interfere with ohmic sensing. Another issue is that splashback from the water in the tray can cause dross to accumulate on the underside of your part. Typically, this type of dross is very difficult and time-consuming to remove. Finally, the water in the tray quickly becomes contaminated. Now, how to properly dispose of this toxic mess can be a difficult, time-consuming, and potentially expensive process. Also, keep in mind that Hypertherm recommends against cutting aluminum on a wet table. This is because it's possible for hydrogen to accumulate in pockets underneath the sheet and possibly explode. Now, because of all these reasons, a dry or downdraft system is considered the best solution. This type of design is where the sides and the underside of the table are enclosed and an exhaust fan is attached to the end of the table. The high-performance extraction fan creates a vacuum and sucks out the smoke and fumes. Typically, a duct is attached from the fan to the outside of the building. While the plasma is cutting, the extraction fan creates the vacuum to draw the smoke and particulates away from the table and vent them outside. No matter how closely spaced your slats may be, it's guaranteed that some smaller parts will eventually fall down between the slats. Now, where they end up and how you get them depends entirely upon the design of your table. Some tables have nothing below the slats. The parts and dust simply fall straight onto the floor. Better tables have collection trays. Now, some trays simply sit on the floor. Problem is, this creates a gap between the bottom of the table and the collection tray below it. With the bottom of the table being open like this, there's no way an exhaust fan can properly draw the smoke away from the table. A properly designed collection tray will fit into a slot into the table itself and won't just sit on the floor. A small attention to detail makes the process of small part retrieval and table cleanup much easier. As discussed before, the best quality plasma tables will have welded steel frames, but are therefore quite heavy. Rollaway wheels allow one person to easily move the table, but the best quality wheels will also have jack pads built into the caster mechanism. This allows the table to be leveled after being moved into position. Again, this attention to detail can be a great space and time saver. Ball rollers are used for loading material onto the top of the table. They're attached along the top of the frame and allow the user to more easily load and position material. Limit switches prevent the torch and gantry from crashing due to accidental over travel and thereby becoming damaged. If a part design is too large or the table isn't indexed properly, limit switches will save the table and equipment from damage. It's important to make sure that all three axes are protected in all directions. Homing switches allows the user to index or reset the table to a known 0 point or offset position. This enables the user to utilize work offsets, which allows the operator to reposition or index the torch to the exact same location time after time. This feature is essential when tiling or cutting oversized parts which are bigger than the table itself. Proper wiring is a necessary part of any quality plasma table. Ensuring adequate cable protection is the mark of a quality table. Lower cost tables often don't route or protect the cables properly. Professional tables will always include a protective E-track or carrier to protect the wiring from snags and damage. By far, software is the most important and essential aspect of owning a plasma table. You'll quickly hear terms like CAD, CAM, and CNC. Now you can physically have the strongest, most powerful table, but if the CAD, CAM, and CNC don't work well together, plasma cutting can be a very difficult and frustrating experience. Let's start by defining some terms. CAD stands for computer-aided design. CAD programs basically help you draw parts. So in order to design and cut a custom part, you must first start with a CAD program. CAM stands for computer-aided manufacture and is a software program that tells your plasma table how to cut the parts that you just designed in your CAD program. Simply put, CAD designs the parts and CAM cuts them. Finally, CNC stands for Computer Numerical Control. It refers to the program that controls or moves your table. Plasma tables that use different software programs for CAD and CAM means that you need to learn two entirely different programs that aren't in any way related to each other. Now, it's best to choose a table that uses the same software program for both CAD and CAM. Now, most plasma tables are going to use a CNC software or Windows-based software program such as Mach 3 to run the plasma table. A better solution, though, is to use a dedicated standalone professional control panel such as a CCM 4D controller. Dedicated smart controllers like this one mean that you don't even have to maintain or learn a CNC computer program. They're much easier to use, they're more powerful, they can't get viruses, and they don't suffer from lag like a Windows-based system would. Another advantage of a dedicated controller is that most feature an integrated library of pre-designed parts. Typically, these can be manipulated in size, the number of holes, even nested. With a dedicated parts library, you don't even need to learn a CAD or CAM-based software program as long as you're cutting parts from the library. Further, custom design or frequently needed parts can always be added or saved to the controller memory, making it even easier to cut parts. Another important consideration is that of tech support. Tech support varies enormously. Some companies offer literally zero support, no phone calls, emails, nothing. Others only offer tech support via email. Now, some companies claim to have an all-in-one telephone support number, but when you call them, it's a recording and you're forced to leave a message and wait for them to call you back. Our best advice is to do this. Before you buy a table, try to call the company and get a hold of tech support. You may be surprised at how difficult a task this turns out to be. All right, so let's talk for a moment about pricing. Software programs differ enormously. While some are completely free, others can cost several $1,000s each and every year in subscription fees. Another thing we should talk about is software locking. Some plasma table companies sell their tables at a lower cost, knowing that later on, the customers will be forced to upgrade their software. This is because they intentionally lock out the most important features of the software, like advanced design, nesting, height control, and ohmic sensing. One very notorious plasma manufacturer charges around $1,000 each for 6 different unlock codes. So when you're considering the purchase of a plasma table, make sure to ask if you're getting the fully upgraded, completely unlocked version of the software. And if not, what's the exact cost of upgrading before you buy? It's extremely important to ask these questions first before it's too late. Now, in order to get the best cut quality possible, it's important to maintain the correct height between the torch and the material at all times. The program that controls this is called Torch Height Control, or THC for short. In general, there are 2 distinct times that THC is important. First, when the torch initially touches the material, and second, while the torch is moving or cutting. If the correct height is not maintained, it can cause the consumables or the user replaceable parts of the torch to become damaged or consumed very quickly. Now, some plasma tables have no form of torch height control whatsoever. Other tables may list THC as optional or as an upgrade. Now, customers who buy these tables without realizing the importance of THC can be found everywhere on the internet complaining how terrible their cut quality is and asking for advice on how to make it better. Unfortunately, there really is no substitute for good torch height control. You simply have to have it. And as previously discussed, some manufacturers sell their tables with the THC function intentionally locked out. Unfortunately for these unwary customers, the price of activating this feature often costs several $1,000s in unlock codes. Now, torch height control is actually comprised of 2 different parts. The first form of height control is known as pierce height. This is the distance at which the torch first pierces or cuts into the material. The worst method is where the customer must manually position the torch. Not only is this method very imprecise, it's also very time-consuming. The floating head method is a second best way to set torch height. This is where the torch is mounted on a vertical slide. When the torch is driven downwards and the tip of the torch pushes against the material, a limit switch is activated and sends a stop signal to the motor. The problem with this method is that the torch must physically push down against the material in order to trigger the switch. On thin materials, this method is not very accurate, as a thin material can easily deflect before the switch is activated. This leads to an improper height signal, which, as discussed earlier, can reduce the lifespan of your consumables and also degrades the quality of the cut. The benefit of using a floating head system is that it does not rely on the material being conductive and therefore works very well as a backup for materials that might be painted or rusted. The best way to set pierce height is referred to as ohmic sensing. This method very precisely measures the resistance between the tip of the torch and the material. As the torch is driven downwards, it immediately stops moving the instant the tip of the torch touches the material. For this reason, ohmic sensing is by far the most preferred method of determining pierce height. This is especially true when cutting thin materials, as ohmic sensing will not deflect and bend the material like the floating head or stall methods will. Now, one limitation of using ohmic sensing is that wet or water-based tables can cause it to misread. So in summary, the best way to determine initial pierce height is with a dry downdraft table using a combination of ohmic sensing as primary and floating head as a backup if the material happens to be rusted or painted. The second form of height control maintains your cut height. Cut height refers to the distance between the torch and the material as the torch cuts and moves across it. Now in general, there are 3 methods to set cut height. The first and worst is to set it manually. Once again, this is not a precise method, and once set, the height cannot change unless the operator manually does it, even if the material is warped and uneven. A better method is to use AVC, or what's known as arc voltage control. This method precisely measures the voltage between the electrode and the material being cut. It then compares the measured voltage to a preset value previously programmed by the operator and adjusts the torch height accordingly. While the torch is cutting, if the torch moves away from the material, the voltage will increase, and subsequently the AVC program will drive the torch downwards. If the torch becomes too close to the material, the voltage will decrease, which causes AVC to lift the torch up away from the material. The third method of height control is voltage sampling. In this method, the operator programs a specific cut height. As the torch first begins to move, the voltage is sampled and the voltage value is then captured. Now, just like AVC, the torch height is then precisely adjusted to maintain the captured voltage value. This is the best method of arc voltage control. But the bottom line here is that torch height control is a required component to make quality cuts. Make sure that both ohmic sensing and some form of arc voltage control is included in your table, and not another expensive upgrade that you'll end up paying for later. Now, everyone who cuts parts in a plasma table encounters tip-ups. A tip-up occurs when a part is cut from a sheet, but it doesn't remain perfectly flat, nor does it fall completely through the slats, hence the designation tip-up. The problem is, what happens when your torch runs into a tip-up? A breakaway torch mount breaks away when your torch runs into a tip-up, thereby protecting the torch from damage. The best systems use 2 adjoining plates held tightly together by strong rare earth magnets. Embedded steel balls ensure precise plate alignment both during normal operations and after a breakaway is experienced. Because running into tip-ups is a normal part of plasma cutting, having a breakaway torch mount is a necessity. Now, central to the performance and reliability of your plasma table is the plasma cutter itself. How thick a piece of material you can cut relies almost exclusively on which model of plasma cutter you decide to buy. Remember, the plasma table can only guide the torch, it doesn't physically push against or cut the material. While there are many different plasma cutter manufacturers available, most professionals would agree that none can match the quality, performance, and reliability of Hypertherm. Another consideration is whether or not the plasma cutter has a built-in machine interface. Hypertherm refers to this as a CPC port. Now, regardless of the terminology, a machine interface provides an extremely convenient method with which to connect the plasma cutter directly to the plasma controller. Keep in mind that trying to retrofit a machine interface to an existing plasma cutter may very well void the warranty. In our opinion, it's much easier to purchase a plasma cutter which already has this option installed. Finally, most plasma cutters will offer 2 different styles of torch. The first is a curved or handheld type. The second is a straight or machine torch. Professional plasma tables will all require the straight machine torch design. In order to automatically control torch height, the plasma controller must get feedback from the plasma arc. Under normal operations, a typical plasma cutter puts out between 68 and 160 volts with a potential momentary 300 volt output in the event of a consumable failure. Now, clearly it's not safe or practical to feed a 300 volt signal from your plasma cutter all the way through the plasma table and back to the controller. Therefore, Hypertherm plasma cutters have an optional internal voltage divider to reduce the electrical signal to a safer, more manageable level. The internal switches are user selectable and are typically set to the default 50:1 setting in order to bring the electrical output down to a more manageable 6 volts. Now, all plasma cutters require a reliable source of clean, dry air. This can either come from bottled air or an air compressor. If you use an air compressor, it might be necessary to route the air through an air dryer before it gets to your plasma table. And don't forget about the performance specs. As an example, Hypertherm recommends a minimum of 6.7 CFM at 85 psi for their Hypertherm 45 XP. Now, don't overlook the importance of properly planning for the electrical connections. Most plasma tables will only need 110 volts AC, but typically a plasma cutter and air compressor will most likely need 220 volts AC each. Now, proper grounding is also important. Best results are obtained from a dedicated grounding rod installed right next to the table. It's imperative that the plasma table you choose is equipped with the necessary features to allow it to cut properly. Although some dealers may try and lead you to believe that ohmic sensing, arc voltage control, and many of the other features that we've discussed are simply options, they're really not. They're essential in order to cut properly, and you should not buy a table without them. The best advice we can offer you is to be very careful when looking at plasma tables. And probably the most important advice we can give you is this. Remember, the plasma table will not operate without the software. The only way to properly evaluate a plasma table is to see a complete and clear demonstration of the workflow all the way from start to finish, i.e. from part design all the way to cutting. Don't believe anything until you actually see the entire process for yourself. If the company doesn't have a clear, easy to follow demonstration video showing this, then their software is probably not as easy and clear to understand as they'd have you believe. Well, thanks for taking the time today to watch our video. If you're seeing this on YouTube and you appreciate the job we've done, please make sure and give us a thumbs up. And don't forget, we've got a lot more information about plasma tables on our website at www.arcstar.com. So remember, when you're in the market for a professional grade, easy to use plasma table, go ArcStar.